Okay, now if we use a principal component here, what will happen? So principal component, I have to add the life expectancy and then create using all the principal component we have, right? And then we do the let's use only 3, right? And run the regression using the principal component, only first 3 of them. So we do the regression, and then if you take a look at our R square is already 96.9. We got a R square here without principal component. Actually, our R square, when we use all of our data, how many independent variable we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We use a 10 independent variable, and we got the R square 97.5. But here I use only 3 of them. I can get 96.9. So if we use let's use one more. Now it reached the 97. So in that way, mathematically we reduce the number of independent variable. Still, we don't lose much information. We still maintain pretty good R square, right? Of course, this is not as much as the using R square using the all 10 independent variable, but as you can see here, we maintain pretty good. Actually, the fourth one is not significant. It's like p-value is like 14%, but it's pretty good, right? So we need only 3. Using 3 or 4, then we can reach the similar accuracy with like a 10 independent variable. This is the why we call this is the dimension reduction. However, many cases we don't use a principal component. Why is that? It seems it's always better, right? We don't need a 10 independent variable. We can use only 4 independent variables. Still, we can get a pretty good accuracy. But why we are not using the principal component every time is because it's hard to interpret. If your objective is just to make a correct prediction, then you can use you should use the principal component. You can reduce number of variable. However, if you want to know what effect what, and then what kind of thing will have a negative effect or positive effect, you want to see that kind of impact or effect of the certain things. This is gonna be really hard because PC1, okay, I found the PC1's coefficient is minus 3.7, right? So PC1 increased by 1. Our life expectancy will decrease by 3.7. Now, what is the PC1? PC1 is the linear combination of all the variable we have, right? All the 10 variable we have. Even though there is a coefficient here, right? Coefficient here, but it's not gonna be easy to see. If that ratio is increased, then PC1 will increase. Okay, how much is it increase? It's gonna be really hard. I mean, you can do that. Still, you can find out what is the death rate. It will be the positive coefficient or negative coefficient. You can find it. However, this is gonna be really complicated, right? So when you're trying to minimize the independent variable and holding the accuracy, your objective is just making the correct prediction. Prediction itself is your main objective. Then you can use a PCA. However, you use this linear regression trying to find out what caused what and what affected how much. Then if you are trying to find out that kind of the information, then PCA will make it hard to interpret. Okay, so that's why we are not using PCA all the time. But when we have a really large number of independent variable, you want to reduce the number of dimension, then PCA can be one of the good tool. Okay, that's it.